All right, guys, welcome to the eighth instructional video for Math 1. It's kind of crazy that we already made it this far, but it's going to be a great lesson. Hopefully you guys are doing well. I think this is, not I think, this is for the Monday's lesson, so hopefully you had a great weekend. If you are working on your computer, you want to make sure that you get your document up. You can find this on lesson 8 in Google Classroom. If you have the paper document, you can follow along and take notes with me. And if you feel like it'd be better to write in your own notebook, that's also great. Note taking is an amazing skill to have, especially if you want to use it in college and beyond. And another thing you can do if writing is difficult, your hands can cramp up, there is a text to speech function in Google Docs. So if you click on it, you can talk to the computer and it records what you're saying. If you have any questions about how to use that, comment below or message me. But there's a lot of ways that you can take notes. I just want you to feel comfortable, and I want your learning experience to be easy and to be well suited for you, right? This learning is for you, and you are the star of this show. So keep that in mind as we move forward. But let's not waste any more time and let's begin. So I'm just gonna share my screen and let's do this. All right. So this is the document that we have for today on April 6th. Can't believe it's already April. Um, and I had made some edits to the document to make it look a little bit better. Um, just a quick overview of what we're doing today. I'm going to go over our objective. I'm going to read out our notes. I am going to go through an example problem on page 2, and then I'm going to go through another problem for page 3. After that, I will kind of set you up for your practice problems, and you should expect to do your practice problems by yourself, as well as the exit ticket, and that will be it for today's lesson, okay? So keep that in mind. This is what we're gonna be doing. If you have any other questions, obviously, please reach out to me, but hopefully you'll be able to understand and feel comfortable to do this packet by yourself, even without my help. So let's go back to the first page here. All right, so our objective for today is I can create an equation for a linear model. So today is actually a review lesson. I wanted you to feel comfortable how to make equations for a line of best fit, which is something we did on Friday. I thought it would be helpful to kind of go over what is a linear model, right? It's something that we talk about, but maybe you guys need a refresher, or you want to take it to the next level and make these connections, because you can represent linear models in a lot of different ways, which you'll see. But before we begin, I want to go over the why, right? So the big why is, let's say you have a scatter plot, right? So I'm looking at page 1, I'm looking at this scatter plot. If you just look at this graph, it's actually really hard to draw information from it, right? What does it mean? How can we make calculations, predictions based off of it? How do we make it meaningful? The thing about real life data is that it's not perfect. Real life isn't perfect, right? I always say this. And that's totally fine. It would be absolutely boring if life was completely perfect, and our data is just the same. But if we want to make calculations, we kind of have to use models or mathematical models that allow us to make really good guesses, right? So based on this scatter plot, you want to ask yourself, right? And this is the first star bullet point: what mathematical model would best fit this scatter plot? If I want to explain this data, what mathematical model should I use? And the answer is you want to use a linear model, right? If you notice our trend for the scatter plot, it's moving in a linear direction, even though it has a weak correlation, right? Um, and to do a linear model, is the very reason why, and I'm moving to the second star bullet point, that's the very reason why we use a best fit line to make calculations about our data on this scatter plot. If you notice, it's not gonna be the best or like the most ideal way to calculate based on our data, but it is our, oh no, that was grammatically incorrect. It may not be the perfect way to describe our data, but it is probably our best bet. Okay, if I was to bet on anything, this linear model is what I'm gonna be betting on. So that's the big why as why we're doing this lesson. And I want to go over how do we represent linear models. So when I talk about model, just remember it's more of like an example. How do we represent something? Not like a celebrity model. Like a linear model is more of like how do we represent our data. So let's turn to page 2. Oh, one thing, back to page 1. If you guys have any questions on what the best fit line is, please go back to our previous lessons number 6 and 7. I do go over this, so that should be helpful if you feel like this is new information. So let's go to page 2. Now, we're gonna be asking the question, what is a linear model, okay? And when I'm thinking about the word model, as you see in my parentheses, it could mean a lot of different things. And remember, if I'm writing in red, you don't have to copy this down. And if I write in purple, you want to write that down. I will write down important information in purple if you especially want to take note of it. So when I'm talking about model, a linear model, it could be an equation, right? It could be a function, which is something we talked about a couple units before. It could be a graph. It could be a table. It could be a word problem. A model is just basically a way of saying, how can I represent? How can I explain a situation, a scenario? Keep this in mind when I think about the linear model, you want to think about all the ways we can represent something. And it's really just a connection between an independent variable and a dependent variable. So a linear model is basically a relationship between the independent and a dependent variable changing at a constant rate. Oh, my handwriting is horrible. Another side note, thank you all for bearing with me in my handwriting. Hopefully you're able to read it. But basically a linear model is a relationship between the independent and dependent variable changing at a constant rate. That's going to be really important in understanding linear models because the idea is that it's changing, or the relationship between the two variables we're looking at are changing at a constant rate, meaning that it's going to go up or down by the same number. So I'm going to erase all this and just kind of do a quick TLDR that I'm going to keep up here in case you guys get confused as we're doing our lesson, okay? And take this, erase all this, okay? So our linear model, right, changes at a constant rate which means goes up, down by the same number for our variables, okay? I'm gonna make a little cloud around that to make it look cute. Okay, so let's look at a situation. So Sally's younger brother, Sam, has 4 quarters. Sally gives him 2 more quarters every week. How can we represent this situation using a linear model? So take a moment and pause. I just threw out a lot of information at you. Take a moment and pause and think about the situation. And ask yourself these questions. How many quarters does Sam start off with? How much money does Sally give him? What are some questions that you have about the situation? Okay, pause your video. Ask yourself those things. Okay, hopefully you pause and were able to give a moment. Some questions that you guys might have asked is, how many weeks has Sally been giving Sam quarters? Why is Sally giving him quarters? Like, that's such little money. And how much is Sam saving up money for something? These are all questions you can be asking. Now, in order to represent the situation, we want to find ways we can model it, right? And we can model this situation with a linear model because it's changing at a constant rate. Every week, Sam gets 2 extra quarters. It's never changing. It's always the same. So we know this is a linear model. We're going to do a thing where we're going to go from equation to table to graph, okay? But before we do that, I want you to pause again because that's also a lot of information I just threw at you. Let's give you a moment to look over this. And I'm going to go on to page 3. All right. Can we go the other way now? We're going to go from graph to table to equation, which is what we will be mostly doing for our scatter plots. Now, I'm trying to get through this quickly. I feel like this video is going on for so long already. So first thing first, we have our graph, right? When you want to think about a linear model, you always want to think about this, okay? What do we know? What do we not know? Okay? This one, it's always going to be our x, our y, or our independent, or our dependent. I'm going to color code it again, right? Pink. Oh, I kind of switched it up. It's going to be orange and pink. Orange and pink. Okay. What do we know? Basically, we need to know our slope and our y-intercept. Okay. Color coding that again. Our slope is green. And our is blue. Our y-intercept is blue. If you look at this graph, we need to think about, okay, what's our rate of change and what's our y-intercept? Our y-intercept is basically where it crosses the y-axis. So where is that point? Oh, what happened? Oh. Our y-axis is right here. Where does it cross? We know that it crosses at 5. So that is our y-intercept. Now we're looking at rate. There's a couple ways we can do this, but the way I want to show you how to do this is you could do rise over run. Or we can do change of y over change of x, right? And then I'm going to say is our y-intercept where it crosses the y-axis. I'm going to write down the side. Okay, so here we can notice that it goes down 2 over 1. So our slope is 2 over 1. But I'm going to show you how we can do that on the table as well. So let's look at this graph again. At 0, what's our y value? It's 6. At 1, it's 3. 2 is 1. And 3 is negative 1. I'm going to look at our rate of change. So for our x values, we know that it goes up by 1. And for our y values, we can do it goes down by 3. Now, this is going to be our change in y, and this is going to be our change in x. So our slope, once again, oh, no wonder. This is supposed to be 5. My bad, that's negative 2. My bad. Our slope is going to be negative 2 over 1. Now, it's really important. I made a mistake here, right? This is supposed to be negative because our slope is negative. So make sure you keep that in mind. Now that we know these pieces of information, you can just write your equation. Basically, it's going to be y equals negative 2 over 1, x plus 5. because y equals mx plus b. We figured out m, we figured out b. That's how we get our equation. Now, this has been a moment where I really wish that I could see and help you with your problems, but I'm going to just move on to the next page because I think helping you with these practice problems will be the best way for you guys to understand. The way I want you guys to think about this is that you'll always want to have two things that you know, and you're going to find those out. And then the unknowns are always going to be your variables, X and Y, your independent and your dependent. And remember to look back at the real life situation to kind of make those connections that you need. But if you're going from graph to equation, that's what you want to do. You could find your y-intercept, use a table to figure out your rate of change or your slope, and then you create an equation based off of that. So for our practice problems, please take a moment. I do really want you to try the link here if you're working on your computer to create a linear equation. To have all that practice is really important. It also tells you whether you get it right or wrong, so I can give you that immediate feedback. But we're gonna go over the question number 2. You're gonna write down your answer here in yellow. Every time there's a yellow box, it means that you're writing your answer down there. So we're trying to figure out this question here. Which of the following equation represents this line on the graph? You have your answers A, B, or C, and you want to figure out what it is. Just a reminder, right? Our equation is y equals mx plus b. M is your slope, rise over run, rate of change, change in y over change in x, and b, this is all like different ways to like think about this, all means the same thing. B is your y-intercept, or so to speak, starting value. Okay. Oops. So pause your video, answer number 2, and then double check with me. Unpause the video to see if you got the right answer. Okay. So hopefully by now you paused the video, you looked at the graph, and you were able to see whether it's A, B, or C. And I'm going to show you the correct answer. So in this case, right, the graph is kind of hard to see. The correct answer is B, and you would write down your answer here. Excuse me. So how did I figure that out? The first thing I would want to look at is the y-intercept, right? Where does the line cross the y-axis? So the y-axis is right there. It crosses here. I know that it crosses at -3. So it's actually really easy because if you look at here, that's a +3, so I know that can't be it. This one's a -3, so I'm like, okay, maybe. And if I look at here, that's a +3 again, so I know it cannot be that. So even if I don't check the slope, I know that because the y-intercept is correct, our answer is B. Okay, so hopefully this kind of helps you understand what a linear model is. There's a lot of different ways to explain it and describe it. And so hopefully you guys can make those connections, right? And this is the kind of higher level thinking that you want to be doing when you're thinking about the models that you're using to describe your scatter plots. Your goal is to finish the practice problems on page 4, 5, and 6, including the exit ticket. In this case, you're just solving the multiple choice questions between number 2 and 5. For number 6, 7, 8, and 9, you are creating a equation y equals mx plus b. So you want to find slope and y-intercept to figure that out. For number 10, I want you to go and reflect on what y equals mx plus b means. Like, what does the formula mean? Because you need to understand that to be able to answer your questions. And for your exit ticket, once again, you want to create a linear equation for each of these graphs. So let me just write down your to-do. Okay, complete this packet by Friday, which I believe is going to be 4/10. Okay. Let me know if you have any questions. Message your teacher. Any questions, and see you at our live session. on Tuesday, which is tomorrow, we're gonna do Google Hangouts. The link will be posted. So please, it's the same link. Hopefully you guys can save it and just join in. That is when I can really help you with these questions, okay? So thank you so much once again for listening through all this. It was a lot of information. Hopefully it wasn't confusing. Hopefully math was impossibly easy, and I'll see you guys next time. Bye.